Hey folks, welcome to part 2 of our titratable acidity calculation. So I have here our titration sheet template from our master class, and let's just go through this real quick. So let's review what we were doing before. So we have here the sample name. So let's say for here, for example, we're calling it final product, or let's just call it cucumber kombucha, and then let's just call it CK1, and then the date, which let's say it was from June 8th, June 2nd. We're going to June 2nd. So June is 06, and then second is actually, let's just go for the international way we write things. So 02-06-2019. Voila, that is the sample. And so you can see here we have the weight for 1, 2, and 3. So I'd like to do the sample 3 times. I'll do the sample 3 times because whenever you're doing titratable acidity, sometimes there's something you mess up. And so by doing it 3 times, you'll know that if one of those 3 messed up, you could just take the 2 other ones. And what it does here is it does the average. So if they're all pretty close to each other, it just gives you the average, which actually gives you more precision. So let's get started. So as you saw in the video previously, we measured the weight of the container. Let's say the weight of the container was 19.01. We're not going to put the weight of the NaOH. That is extrapolated at the end. There's a formula here. So basically you subtract. There's a formula up here. Basically we're subtracting everything from their total weight, and then it'll give us the weight of our NaOH at the end. That's kind of the mystery value that we're looking for. So kombucha. How much kombucha did we put? Let's say we put, let's put 21.04. So water, let's say we put 25 milliliters of water. That's approximately what I like to put. So, and then let's say that the total weight was, I'm going to estimate, or let's just say that the total weight on this thing was 72. Boom. 72. Let's make the numbers look real. 72.03, and the concentration of our NaOH. So that is, it's important to get a reference solution. You can make it yourself, or you can buy it. It's always better if you buy it. But let's say you have a reference solution, and your reference solution is in normalities. That's right here. So whether it says M or N on it, for NaOH, sodium hydroxide, it is the same thing. So we're going to put 0.1. I like to work with that. 0.1 is not even dangerous. So now what we have here, you can see the calculation here. So C1V1 equals C2V2. And then times 6.4. So 6.4 is the unit that we use to go from normalities or normals of sodium hydroxide to percent citric acid equivalents. And so it's not important to really, it's not important to understand this because if you have access to this sheet, or you can actually just duplicate this sheet on your own, and using the 6.4 unit and conversion, you can see here that the concentration in citric acid equivalents of this product was 0.2123. There's a little bit too many numbers here, so let me just reduce this to, let's just give it 2 decimal points. You don't really want more than that, because they're just making them up anyway. Okay, so 0.21. And so now what you can do here again is do more or less the same thing. So we'll just redo the same thing. So my container, it's the same container, so it weighs the same, or let's say it had a couple drops of liquid on it, so now it weighs 19 point, oops. So that's what not to do, is do not erase this formula. 19.1, boom. And then kombucha, let's say I'll put 22. Water, we'll put 25 exactly. And then this time instead of 72.03, it gives us, let's say 73.45. Now put our concentration of, and we're getting 0.21. Perfect. That means it's pretty much the same. Now they look exactly the same, but if you actually look here, they're a little bit different. This one's 0.212. This one's 0.214. And let's just say that we do a third one here. So 19 point, let's go 32. There's a, now it's going to be 0.15 because there's a drop of water in there, another drop of water. So don't erase that formula here. kombucha grams. How many are we putting? We're going to put 20 this time, 20.03. Water, 25 again. And then let's just say that this ended up being 74 this time. 74.23. Boom. Oh, it's not giving me my data here. It doesn't give me my answer. Why not? Well, because I need to put boom. So so this one here is a little bit higher, 0.32. So what you can do here, there's two things that you can do. You can either just go, okay, 0.212, 0.214. I'm going to put it as 0.213 because this one is obviously a little bit off. There might have been something that you did. Maybe misread a number, maybe put a little bit more, a little bit less of something without writing it down. But basically, this allows you to, everyone's going to make mistakes, but this is going to allow you to see where you might have made a mistake. And this is why I do 3 of them. So here, I'm just going to put it as 0.213. So I'm going to go over here, 0.213%. My units are citric acid equivalents. Now, remember, not citric acid, but the equivalents, because we don't know what the mix of acids is exactly, and each one has different grams. And because of stoichiometry, you need to choose an acid if you're going to turn it into percent. Blah, blah, blah. The date tested is 02/06/19, and the name of the product was cucumber kombucha. There you go, voila. And then who did this? Mr. Seb. I don't know if there's a dot at the end of Mr. Seb or not. And so this is a basic way of just registering all of your data. Now there's 1, 2, 3, 4 sections here. Now they're exactly the same. It's just so that you can do 4 titrations at once if you want to, if you don't want to kind of get stopped. Or you just want to do 1 operation at a time, this way you can do 4. Now what you want to do, or what you can do, there are different ways of keeping this data. You can always duplicate this sheet if you want to keep it as a background, or you can delete this sheet, or you can delete the numbers in this sheet right here and clear it up like that, and so on and so forth, and then just restart every time. And that is how you go from measuring your titratable acidity to converting it into your percentage citric acid equivalents. Thank you.